right, welcome back. So we're gonna start the next objective here is to show use initial conditions to find particular solutions of indefinite integrals and real life problems. All right, so although it's very common for us to find that indefinite integral with the arbitrary constant c, there can be some instances where we're gonna be given an initial condition or a particular condition of the original function. Thus, we can use that to actually find the original function, right? So we can actually go beyond just leaving it as plus c, but we actually can find the actual function. So example 4 is the perfect model where we can do that. So let's say if the marginal cost for ski gloves is MC bar, the marginal of C bar equals 5.5x plus 9.5 with a fixed cost of $416. That is that C of 0 is equal to 416. Find the total cost function. So we'll talk about what does it mean fixed cost and how do we translate that to be this, right? In a second. Okay, but let's go back real quick here and think about what they're giving us, right? They're giving us the marginal cost, which marginal means the derivative of the cost. So think about that this is the derivative. And they're asking us to find the total cost. The total cost, by definition, is the original function of the cost function, right? This is the total cost. So we're looking for the total cost, and if we want to translate this, they're giving us m bar of c, which is c prime of x, right? That's your c prime of x. So that's how we translate this, right? All right, so we're given this, right? And our goal is to find the original cost function. So I'm gonna show you guys how to maybe think about this problem. So our goal is to find the original function, right? But we're given the derivative of the cost function. So the difference between those two is that this is the derivative and this is not the derivative. This is the original function. So would there be a way where we can undo the derivative of the function? And the answer is yes, right? We can undo the derivative by taking the antiderivative. And I'm going to put this in blue. So we're going to take the antiderivative on the left side, but whatever you do on one side, you got to do it to the other side. Do you guys see what I mean there? So by doing this, these two should cancel each other out, right? The antiderivative and the derivative should cancel each other out. And then you're left with c of x, right? And then so c of x is going to be the antiderivative of 5.5x plus 9.5. So let's do one. Let's take the antiderivative of one of each term. So this is the constant multiple rules. That means that you carry the constant because it's a product as a factor of this function. And then you, for the x part, you always think that there's imaginary 1 there. And we apply the power rule, which is add 1 and then divide by the new power. For the constant, right, then we just add the factor of x, right? And don't forget to always add the c, right, the constant, the arbitrary constant. So there you go, right? So we have found that the total cost function is going to be x squared over 2 plus 9.5x plus c. There you go, right? So can we maybe think about rewriting it here just so that we can see it what we have, right? All right, so this is the cost function, but we still don't have like an actual. We don't have actually that. We don't know exactly what is the cost function because we don't know what c is, and this could be anything, right? So if you think about it, they actually give us that information here, and the way we translate fixed cost, we translate that to be the fixed cost is, think about it, is the cost that does not depend on any unit, right? The cost, for example, That's like the cost of renting a storage room where you're gonna put your factory, right? Just by the renting does not depend on how many units you're building, right? The cost does not depend on whether you're gonna need to buy tires for a bicycle, buy some metal, right? So that would depend on how many bicycles you want to make. But fixed cost is just it does not depend on the number of units you're gonna produce, which means that that's gonna be the cost of producing zero units, right? Because at 0 units you haven't produced anything, but that tells you exactly how much you're spending just to turn on the machine, just to turn on the factory on, right? So think about that. This are the same thing, right? And I hope that you guys keep this handy somewhere to always remember that fixed cost is the same as C of 0. So since fixed cost is C of 0, why don't we try use that to help us find C. So let's go ahead and do that. So we're gonna replace where we see a x, we're gonna replace it with 0, right? So let's see what we get. C of 0 is gonna be 5.5. 0 squared over 2 plus 9.5 times 0 plus C. And as we expected, 0 squared over 2 is 0 times 5.5 is 0. 9.5 times 0 is 0. So, and by the way, this is supposed to be what, equal 416. So that means that 416 is equal to 0 plus 0 plus z, right? Which is, in other words, 416 is equal to c. So we have found the actual cost function, right? That the c value. And now we're gonna go ahead and now we're gonna go back to the problem and see if there's anything else we want us to find. That's it, right? We have found the total cost function. The total cost function is 5.5 times x squared over 2 plus 9.5x plus 416. All right, and that was it. So we have found the total cost function. I hope you guys found this helpful. The takeaway here is A, be able to undo the marginal by taking the antiderivative on both sides of the equation. And the other thing is to be able to translate what does it mean to a fixed cost. That means that is C of 0 equals 416, which will help us find our C. Anyways, I hope you guys found this helpful. Please let me know if you have any questions. I'll see you guys next time. Thank you. Bye bye.